Securing the American dream for the next generation of STEM and workforce talent. My name is Matt Kirkner. I am your host for the Tech Ed podcast. You know, we talk about that every week in our intro. We talk about securing the American dream for the next generation of STEM and workforce talent. Of course, here at the Tech Ed podcast, we love STEM. We love STEM education. That, of course, standing for science, technology, engineering, and math. But if we're being honest, we probably spend a little more time on the two middle letters, that being the T and the E, the technology and the engineering, than perhaps we do on the science topic. That all changes on this week's episode of the Tech Ed Podcast. We're really, really honored and happy to welcome in to the studio of the Tech Ed Podcast, Dr. Julie Panepinto. And Julie is the director of the Division of Blood Diseases and Resources at the National Heart, Lung, and Blood Institute of the National Institutes of Health. Yes, I had to read that entire title. That is an incredibly awesome title. Dr. Panepinto, we've been friends a long time. I'm comfortable calling you Julie, and it's my pleasure to welcome you to the Tech Ed Podcast.
Thank you, Matt. It's wonderful to be here. Glad to be able to share.
So what an incredible career you've had and continue to have. And just want to, as we familiarize our audience with the amazing work that you're doing, want to give them a little bit of a sense for how you got into the world of medicine in the first place. Tell us what inspired you toward your current career.
Sure, I love that. So I grew up in a family of physicians. My dad's dad, so my grandfather, was a general practitioner, so did everything from delivering babies to taking out appendix to just taking care of a common cold. So I can remember distinctly, spending time with him and learning about medicine. And then my father, who was a cardiologist, and getting to shadow him in medical school. So I had the influence in my family. So that's probably first and foremost. But I loved the science, and I can remember kind of in a weird way dissecting a frog in biology. And that's where I was like, oh, this is kind of not my thing to look at frogs, but I love the concept of what's involved with how the body works. And so really that science is what continued to lead me down the path, knowing what the profession looked like as a whole from the family influence.
No, you're taking me back in time to my time in high school dissecting a fetal pig, actually. That was an experience that I will never forget. Wasn't inspired quite on the same career pathway that you were, certainly having that medical background in your family, your grandfather and your father. I won't make the obvious pun that medicine was in your blood, because we'll be talking about blood a lot in this particular episode. Such an incredible influence that our mentors can have on us, whether that's parents, whether it's teachers, whether it's some other individual in our life. In your case, your father and your grandfather. I've got to believe there were other major influences as well. Any that come to mind?
Absolutely. So, as other professional women have really written a lot about, you really are about your plus one. And so for me, that's been my spouse, David Brousseau, who also happens to be in medicine, as a leader in medicine, but clearly, without his support, not only professionally, but personally for our family, I wouldn't have been able to make the big move geographically and really just at that point in my career. And my decisions in my career clearly influences his career development too. So this was really an incredible display of support that allowed me to advance my career in leadership at that point in time.
What a great opportunity. What a great marriage. And for sure, I mean, having the support of your spouse is absolutely unequivocal in terms of where your career goes, and making sure that goals remain aligned and that families remain productive, and that part of our life is so very important. I agree 100%. I'll also echo your sentiments. So full disclosure, your husband, Dr. David Brousseau, is one of my best friends, and somebody I've known a long, long time, and there's no better person of character on the planet. You're fortunate to have him as a husband. I'm fortunate to have him as a friend, and I really appreciate you taking a moment to highlight David as well. Tell us a little bit about why you took that step from, kind of more of the patient care side to the research side at the national level.
Yeah, so I think it's probably multifactorial. One was first and foremost personally, my children were more or less grown, and they were on their way to independence, having left high school. So where I was grounded as far as geographic location um, didn't matter as much from my professional standpoint. And then professionally, uh, I loved my job of taking care of patients, loved being able to do research, but as I continued on my career, I was looking for more leadership, looking for something to continue to challenge me. And this position here included not only the ability to stay involved in science, it brought a whole new challenge of being involved in a very different way, and broadened my connection to science to not only pediatric blood disorders, but to really all of blood science. So it's been a wonderful pivot, and I learn something new at least a few times a day, and I love that. And it, really has worked out well. So.
Really speaks to the advantage of being in a career where you are learning new things every day. And I think that's as we kind of spend time in this era of lifelong learning, and more individuals are realizing that what we might have learned 10 or 20 or 30 years ago isn't going to carry us necessarily through an entire career. And really having that curiosity and that excitement and energy around learning really important, especially as you're entering or have entered into this role that you're in now, Julie. We talked about dissecting frogs. We talked about dissecting fetal pigs. We're going to dissect your title a little bit, because as I introduced you to our audience early on, there's a lot of things going on there, and so let's talk a little bit about everything you're doing. Just start by the National Institutes of Health. What should our audience know about the work at that level, and then we'll dive down a little bit deeper into some of the work that you're doing.
Surely. So the National Institutes of Health is really charged with really leading biomedical research for the country and even globally. So within that, there are multiple institutions, largely divided by maybe the diseases that they encompass. So for our institute, the Heart, Lung, and Blood Institute, we think about research and want to advance scientific discovery in those areas. And then if we think about it, what I oversee, which is the blood division of the Heart, Lung, and Blood Institute, we oversee what we call extramural, and extramural means our external community. So the external community's focus in blood disorder research that's based in classical hematology, so doesn't involve blood cancer, which would go to our National Cancer Institute. So that encompasses a lot because blood sort of is everywhere, we like to say, and very important part of our existence. And so my job is to oversee about 30 staff who help our external community think about advancing science and blood disorders, submitting their ideas to us for funding, and then getting them to funding and getting them through the success of that grant to advance scientific discoveries.
So if we walk our audience through that a little bit, we've got the National Institutes of Health, and then underneath that, if you will, the National Heart, Lung, and Blood Institute, and then as a part of that, the Division of Blood Diseases and Resources, of which you are the director. You mentioned funding. You mentioned this extramural. Just give us a little bit more of a sense for you're overseeing the funding with these partners. Is that a big part of what you do?
So we have a budget every year that it's really appropriated by Congress, and with that budget, we then utilize that money to grant fund grants in the blood disorder space. So that's really sort of how it works. We do have some partnership with other federal agencies where we collaboratively work side by side. So CDC, for instance, where we're working in complementary spaces and we're trying to further discovery science with CDC, who's doing surveillance work or population based work. So that's just one example of partnering. We also are charged with educating, so educating others in scientific careers in blood disorders and trying to keep that kind of career pathway going. In addition, we also have a responsibility to the public, so making sure we're educating the public not only about the research discoveries in the blood disorder space, but also on the diseases that we serve.
Plenty of things to keep you busy without question. And when we think about funding, and we talk a lot more on the education side, probably in the case of the Tech Ed podcast with R1 research institutions and so on, that are performing research in a wide variety of different endeavors. Is the research both private and public? You're partnering with both types of entities, or tell us about that a little bit.
So we largely grant, I would say the large majority of our grants go to institutions that are public, not for profit, right? So academic institutions. So that's where most of our scientists reside. We do have a very strong portfolio in what's called the small business grant. So there is specific grant opportunities for small businesses to submit their work, often partnering with these same academic institutions or investigators from those places to fund grant and scientific ideas that we hope we're supporting kind of the next step to make those, what we say, commercialize those discoveries. So that's a really nice, also sort of partnering with small businesses.
Absolutely. So a little bit of both, more so on the public side, more so on the nonprofit side and on the academic side, but certainly opportunities for both public and private. Let's dive in a little bit deeper into some of the work you're doing with regard to, let's just say, the current state of research. So when you think, Julie, about advancements in the field of blood diseases, what are some insights that would be interesting to our audience?
Yeah, so we largely deal with blood diseases that are rare, but through a lot of the bench research, we call that our basic science research, we've learned a lot about the stem cells. So the stem cell is what's made in your bone marrow that goes on to make all of your other blood cells. And we're learning a lot about the environment that that stem cell has to live in over time. We're learning the impact of aging, and we're learning how that can influence not only the development sometimes of blood disorders that are malignant, cancers, but also how that might impact what we call cardiovascular risk, so risk to your heart. So we're learning a ton about the blood cell. I think we also are learning a lot about inflammation. So we know that inflammation in the body can also lead to chronic disease. We think to have constant inflammation in the body, right? So that's also largely driven by many of the things we study in the blood space, right? So the blood biomarkers can sometimes suggest a state of inflammation, or even some of the diseases that we take care of can be pro inflammatory diseases just by the nature of how they involve the immune system. So those are just a flavor of some of the things from the basic science aspect, but we've also, as you might imagine, are in an explosion of data. And so data not only from what we call the cell, so sort of genomic or omics data, which is very much at the bench, but all the way to a patient who, when they enter a healthcare system with electronic health record data, every data point there is information that potentially could be utilized to help improve their health outcomes.
We love data. We talk all the time about in God we trust, all others bring data. We talk about data analytics, artificial intelligence, machine learning, just the vast amounts of data now that we have available to us. And it really doesn't matter what part of the economy we're in. We talk about data in the energy space, in the agriculture space, national defense, certainly in manufacturing. I mean, just gathering tons and tons of data, in some cases just for the sake of gathering the data and hoping we can do something with it later. But obviously, the goal is for us to use that data to analyze it and then to move forward toward a goal. So I want to get into that just a little bit, Julie, and talk about the incredible amounts of patient data that I know you have to be gathering and that the world of medicine has to be gathering in general. So, what are the kinds of data that researchers are gathering in their work on blood disorders? And then, how is all of this data managed and analyzed?
Great question. So I think one of the areas probably common to most of medicine, and that's really probably been at the forefront, is imaging. So in the blood disorder space, imaging that can help us detect blood cells that typically, a human is looking under the microscope. There are some automated ways that came much before, which probably is a form of sort of artificial intelligence. But now I think we have the ability to also, I don't want to say come to a diagnosis, but more description for the clinicians to better understand what the blood smear might be suggesting. So, are those cancer cells that we see there? So, it's the type of cell. In our world, we think about things like, do the cells suggest an underlying genetic anemia based on what they look like? And then it's also good at quantifying, so the amount of the cells. So, does it suggest you have too low of a white count or too low of a platelet count or a red cell count, which can lead to blood disorders? So that's a pretty cool thing that I think is true in almost any field is the imaging. There's lots of imaging already available that can be put through algorithms to help with diagnosis. And I think the other piece is the patient. I touched on that a little bit, is so the patient record in and of itself. And so I think the way that's probably already in play is in a predictive modeling standpoint. So we take information on the hundreds or thousands of patients that have come before the individual at hand in front of the physician and help that physician understand um, risk for certain things. And we can talk about the cardiovascular risk profile. It might include lab values like your cholesterol, it might include your age, your family history, and to kind of put together a profile that suggests you may or may not be at higher risk for certain diseases. And then, even better, suggest potential preventive measures that could lower that risk, right? So, if we talk again about cardiovascular, because it's an easier space than blood disorder. For this, it may be exercise, it may be diet, it may be those easy things, or it could even be a preventive medication. So I think it's really pretty neat. It's more, as you might imagine, it's the computer's acting a bit as a brain, but it doesn't have the ability to have that cognitive. It it's as good as what is fed to it, and so some of the worry is always that we have to make sure it gets all of the information it might need for the patient at hand.
Without question. And I just can't help but draw parallels again into my world of advanced manufacturing. And we talk all the time about, putting sensors on a piece of manufacturing equipment, a robot, for example, so we can measure things like force and disturbances and temperature and moisture, all kinds of, torque, things like that. So we sensor up a robot. And it's not just that one robot that we're censoring. It's thousands, if not tens or hundreds of thousands of robots, and gathering all that data. It's really the same way my wife Renee, who you know well, and I had the opportunity back in the month of November of last year to ride in a Waymo car in Phoenix. So we called an Uber, and right on the Uber app it said, "Are you okay riding in an autonomous vehicle?" And we kind of looked at each other. We're like, "Well, we're in a hurry. We have to get where we're going. Fine, we'll say yes." And literally, this autonomous vehicle drives up, picks us up at the meeting we were at to take us over to a convention center. There's no driver in the car. We're in the backseat of this car and it's driving itself. It was somewhat unnerving. But the reason that works is because, that car is driving around looking at what's a stop sign, what is traffic, what's weather, all of this data, sending it up to the cloud, and then all that data is going to every other Waymo car. And then every Waymo car is sending the same data up to the cloud and back down to our car. And in real time, our car gets as smart as all the cars put together, in the same way that a robot using sensor data and artificial intelligence can predict its own future failure and order its own replacement parts before the failure ever happens. And what I'm hearing is we're really doing the same thing in medicine, where if we can take data from thousands, if not hundreds of thousands of patients, and gather all that data and analyze it using artificial intelligence, using machine learning, find patterns in the data, that's going to give us a much better opportunity to predict a potential future issue, or maybe to diagnose a current issue, than we would have otherwise been able to do, provided, as you point out, I think rightly so, that the quality of the data and the way we're using it is being approached in the right way as well, and that we're driving out things like bias that can result if we use the wrong data, or if we improperly train a machine learning algorithm, we can have all kinds of bad outcomes. So making sure we've got integrity in that process as well. I know that was kind of a long explanation in my world of how all this is working, but am I getting it about right?
Absolutely. It's pretty exciting.
Yeah, it's really, really exciting. So let's keep going. Now we've got the data, right? So we can look at digital data, ones and zeros, picking up, numerical data, trend data, all these other things. Really, that's only half the equation, right? We have this other qualitative side of things. So what is the patient's experience? What are the reported outcomes? Talk a little bit about that qualitative side in terms of the research that you and others are doing.
Sure, I love that because my background was in really trying to research that, partly because the disease I studied, which was sickle cell disease, most common manifestation of that is pain. And so, how does one measure pain? There aren't true biomarkers really that help support that. So, you really need to and really should be asking the patient, right, to rate that for you or to share with you what that looks like. And so there's what I would say objective measures to measure what's really sort of someone's own experience with pain. And you do that with these patient reported outcome measures. And so they're validated surveys that get at what I would say is the well being, which can include physical functioning, might include social functioning, and really just straight out measurement of how they experience pain, how the individual experiences pain. And then those are scored, and those scores have meaning, like any survey, right, that puts a score out. And then the nice thing about that, and this is happening already in electronic health records across many healthcare institutions, is that score is included in your medical record. It can be graphed over time, so you can see changes. The physician can see that at the point of care, that functioning maybe has dipped because the patient filled out that survey before the visit. You can address that within the visit. What's going on? I see that, you're not functioning as well. Let's share that. So I think that's a really neat piece. It's been a hard piece because not everyone has adopted uh, the collection of those tools, but it definitely can be done. And it's being done, I would say, probably in the cancer world and in the orthopedic world, much more than in other areas. And in fact, in the orthopedic world, it's been a really neat tool to better predict who might benefit from things like hip or knee replacement, right? Given someone's current functioning, what does that look like? And will surgery versus just physical therapy help you perform better? What will that recovery time look like? So again, more data. I like to think of it as objective data, but really representing the patient, which is often missing from the story.
Absolutely, objective data, and really, when as I was listening to that answer, that qualitative side, trying to quantify pain, for example, and certainly pain to one individual, I'm guessing, might not manifest itself or be communicated in the same way that pain for another human being might be, and so you're really kind of comparing not just an objective measure, but really trying to understand, to your point, how that changes over time, and maybe how an individual's responses relate to prior responses that they might have offered, and really making sure that we're not just turning this into, let's gather all the data and have a really kind of basic and heartless, to forgive the term, approach to how we're caring for a patient, but also making sure we're listening and paying attention to that qualitative data. And then we have the question of, okay, now we have both, right? We've got the quantitative data sets, and we can compare those to hundreds of thousands of patients. We have the qualitative data. How does somebody, whether they're doing research or treating a patient, bring the two of those together in a way that maximizes the benefits of both?
Great question. So I think maybe you're getting at in some ways this pre-existing data, but it's data that can be collected over time. And how do we incorporate both of them to better serve the individual to advance health outcomes? I think one way, and I mentioned this a little bit, is um, given an individual's preferences, and this is really coming into shared decision making, there's often more than one way to treat a disorder or deal with a problem. And so, ideally, the patient is weighing in on sort of what their preference might be. And that preference can often get at what the most important goal is for them, which might be return to work. For someone else, it might be, I want to run a marathon. For an athlete, it might be, I want to be able to play, right? So the treatment choice, what you're trying to maximize their care towards, very much can be influenced by that personal or qualitative piece. Balanced with what you know in the long run might be, I guess, what I would say the more medical side of it is sort of optimizing their organ function at times, or their ability to perform can be physiologic, right? So you'll know the physiologic piece that you need to optimize that you hope lines up with the same preferences for the patient, right? So that's maybe one way to think about it, which I think is why you considering both pieces of that as you're examining scientific questions, because I think the researcher can be blinded by what they think is the right way to do things, or the right way to fix something or cure something, but without listening to what the patient might want from that can be quite mismatched.
It's interesting, and quite honestly, something I hadn't spent a lot of time thinking about myself, which is, yeah, that plan could be different depending upon the ultimate goal of the patient. And certainly every individual, may want something different out of their care, have a different goal, be working on a different personal goal, looking at a different outcome, and making sure that we're listening to the patient, not just along the way, but also in terms of, hey, what is the end game? What is the goal here, and where do we want to go? So really, really important as we get more and more of this data, both qualitative and quantitative. I want to dive in a little bit deeper into the artificial intelligence side of things, and this is something we've talked about quite a bit here on the Tech Ed podcast. We've had people using AI in sports medicine. We had a guest that talked about that pretty extensively. We had a guest that was on talking about using artificial intelligence to teach young people how to optimally throw a baseball, believe it or not. And we've had that all the way to people that have automated robotic systems with a back end AI platform, to literally where you don't need an individual or a person programming the robot. That's all done by artificial intelligence. We know that that's happening in the world of medicine too. So talk a little bit more about the role that AI is playing in the work that you're doing, and if there's specific breakthroughs or applications that you're really excited about, Julie.
Yeah, I think I touched on predictive risk modeling. And I think I'll use an example of sickle cell disease. Now that we have gene therapy that was approved last month by the FDA, two different gene therapy approaches. We've had bone marrow transplantation, which has also been a curative option for individuals with sickle cell disease, but limited by not having necessarily a donor for every individual. But if we think about being able to predict who might experience these devastating complications, and let's say stroke might be one of them. You don't want to wait until the stroke happens because stroke already, if a stroke has occurred, it's already caused some degree of damage to the brain and some cognitive, problems will arise from that. So if we had a way to predict when an individual was, I guess, their end organs, their brain, their heart, their lung, their kidneys were, not yet affected by the end organ disease, could we offer these curative therapies at that time period before, right? But the curative therapies in and of themselves come with risk. And so that's also some of what needs to go into what you'd call the predictive model of, can we identify the ideal candidate? Can we identify the age before they develop end organ damage that we're trying to prevent? And then present to the patient, we think you're at the highest risk for a stroke. We think you should consider these curative therapies because we think that this will prevent that from happening if you have these curative approaches now as a child as opposed to an adult. That may be just one example. Even those that may experience pain, for example, we know once that happens, that continues to happen. So, you know, I think a risk model that incorporates all of these risk factors could be extremely helpful for individuals with something like sickle cell disease, but applies to any chronic disease that worsens over time.
When you think about just the value of those predictive analytics is the term that we use here quite frequently on the Tech Ed podcast, and to your point, really being able to sit down with a patient and saying, here, here's what we're dealing with. Here are the odds of this, and here's a potential curative therapy that could be helpful, but there's risks associated with that, and here are the odds of that. Here's what the data tells us, and really, with I would believe a pretty high degree of confidence, be able to sit down and say, here are the options, and let's pick the best one for you. Is that, I know I'm simplifying it, but is that what you're saying? Am I understanding that right?
Correct. And I think what we need is just a lot more data. So we need a lot more data points over time, right? So we need to learn more about these curative therapies and how they impact a person's life and their end organs, right? And we need to learn much more about what data we have already to create the algorithms. We're not there yet, but we're getting there.
Absolutely, getting there, and really in every space throughout the economy. I just think it's so exciting, and we talk about some of the scary things related to AI, and you can't, of course, go online or read just about any news source without hearing some of the scary horror stories. And then you have a conversation like this, and you think about how incredibly beneficial this can be to people's quality of life if we use it the right way. We use it ethically, we use it morally, we're thoughtful and intentional about how we use artificial intelligence and machine learning. I think the future is really, really bright and really, really exciting. Speaking of that bright and exciting future, I know you spend, Julie, a lot of time thinking about where is all this going. So if we think for a minute about the future of healthcare, and you've touched on this a little bit already, but how would you, let's say we turn the clock forward 10, 15, 20 years, how is it going to feel different at that period of time than it does today?
Well, that's a great question because, as you know, our healthcare and our healthcare system is very complex, right? And there's this explosion of information. So, even when I trained, we probably had a little bit of genetics in my training, but imagine how much since I trained that we've discovered and I've had to learn and keep up with. So, I think if we think about maybe some of us, what I hope will happen is that there will be the ability really at the bedside with the patient for the care provider to have all of the information they need at hand, which they often have all the information, but it's not synthesized, it's not collated, it's not put together in a way that then is actionable for them to provide the best care they can for that individual in front of them. So that's a bit of like maybe precision medicine, right? And we see this a little bit already with some of the care that's tailored based on, let's say your risk factors for cancer, right? We can detect some of that by doing some testing, right? But I think this is even going further than that, which is taking all of the information at hand based on every patient that came before you and based on your own profile. And then right there and in real time, being able to serve that patient best. So that's probably coming. 5 years is probably very, very optimistic, but we're seeing it in pieces. I think that hopefully will help allow care providers to have more time to really interact with patients and to provide what I would say is more the care I can remember my grandfather providing, which is, he was able to do everything. We can't do that anymore, but I think there's that piece missing where having a provider be able to sort of manage all of your care in a model that incorporates all of those specialists could be really, really helpful because I think as a patient, your care can be pretty fragmented the way things are set up now.
I love the word that you use, which is actionable, which is all right, data's fine. AI is fine, but unless we can have some kind of an outcome that says, all right, here's what we're going to do with that data, it really isn't worth very much. And so I like that word actionable. And I like the whole idea that, as we march toward the future, that the, not just the quality of healthcare, but also that interpersonal side of it, you see continuing to improve, which I know is music to the ears of our listeners and to many, in as much as artificial intelligence, machine learning, all these different technologies that we're talking about today, Julie, are going to impact every space in the economy, of course, including healthcare. What are the things that are going to stay the same? What doesn't change as we head into this future?
Face to face, in person visit, I think is really key. I think there's a lot of advantages to telehealth interspersed with that, but I think that really bedside connection is it's always going to have to be there. That would be my answer to that.
Absolutely. Well, it's interesting as we again kind of turning back into the world that I spend a little bit more time in, and talking about growing companies and growing businesses and so on. And we get the question a lot about, well, what roles are going to be really important in the future, as business in general adopts more artificial intelligence, machine learning, chatbots, all these automated systems for interacting with clients and so on. What is the future for some of the careers, and in particularly maybe business development people or salespeople? And in my opinion, is those jobs become even more important, and that we're never going to lose that need for interpersonal connection, for compassion, for empathy, for people really taking an interest and caring about whether that's a customer or a patient in a way that technology is never going to be able to do on its own. I think it's a really, really interesting observation that you make, thinking about all the myriad opportunities that young people have now as they think about their careers. In specific, even in healthcare, I mean, so many different avenues that they can travel down as they consider a career in healthcare. With all of those out there, Julie, if you're counseling a young, let's call it a high school student, a junior, senior, maybe even somebody a little bit younger, that's thinking about a career in healthcare, why should they think about medical research? Why should that be part of at least one of the choices that they're considering?
Yeah, I love that. So I think if you want an opportunity to really help people, right? So you see people who are ill, and you may have even experienced it yourself or with a family member, and you have that desire to be involved in that from the standpoint of, what can I do to improve someone's health? And so not only does that happen at the bedside with the tools that you have, but it's very, very important to do research to improve what we know, right? So we've come, look how far we've come, right? Who would have thought that we could actually have precision medicine where you might be able to better understand my own risk by doing a blood test, right? And then intervene before I develop that problem. So it'll always be at the cornerstone, right? And I remember telling my boss at my former job, my first boss there, because he would always ask me about gene therapy, and I'd want to go in and talk about something else. Be like, well, what about gene therapy and sickle cell, Julie? And this was 25 years ago. I'm like, ah, if I'm still alive and that happens, then great. And here we are today. It happened in
Right.
December. So, you know, ever being the optimist, gene therapy is here, right? And I think it's life transformative. And I was maybe not such a believer way back then, but look at how the field exploded. So the possibilities are endless if you're a quantitative thinker and you like discovery, and you connect with humans and disease, and I think that's it's a path for you.
Absolutely. I mean, as you're chatting about that, yeah, I'm just thinking about number one, the importance of keeping an open mind. And certainly I can think of things that we're doing today now in some of our businesses where if you had told me that was possible 25 years ago, I would have told you that you were crazy. And the examples are almost endless. I won't even try and fathom or bring them all up. But it's such a different world that we're living in today. So part of what I'm hearing in that last response is, hey, keep an open mind and make sure that we're thinking about the fact that things can change. And even though we think something isn't likely today, 10, 20, 25 years from now, God only knows what could be possible. So that part of it is really, really important. And certainly for our young people considering careers, and just think about the incredible benefit that medical research has across so many lives and so many individuals. And if you really are in the mode of wanting to make the world a better place and wanting to go home from work every day feeling like you made a difference, and knowing that the work that you're doing is having tremendous value for other people, this is a great career path for people to think about. As you were answering that last question, Julie, it brought to mind a couple thoughts. Number one is years ago, in one of our manufacturing companies, we wanted to expand the number of quality inspectors that we had, and we wanted to find the best quality inspectors we could. And somebody came up with the bright idea of doing personality profiles on our best quality inspectors and saying what personality traits were most important in somebody that could do that job really, really well. And then when we went to recruit, train, and promote individuals for that job, we actually did personality profiles on candidates as well and matched those personality profiles with the ones that we knew were the most effective in terms of executing the responsibilities in that particular role within our company. I'm kind of wondering, and is the same thing true of research? I mean, is you're looking at people not just in terms of what their education background is or what their academic qualifications are, but also in terms of the types of people that excel in that space. Are there, and you mentioned a couple already, but are there specific character traits that you feel are really, really important if a student is going to consider this career endeavor?
I think being inquisitive or curious, we call it scientific curiosity, right? Because that's really what you're doing as you're advancing science is you're constantly asking a question, right? And you're trying to understand. And when there isn't an answer to that question, then that's perhaps the area of research that you're going to go because you're driven to try to find answers to those unanswered questions. And so always being curious about the world around you is probably a big component. And I talked a lot about being a quantitative thinker, right? You like to measure things, you like evidence, right? That drives science is the data and the evidence behind, decisions or reasons for recommendations. I think if we think about it from a physician scientist standpoint and a physician where those worlds really collide a lot, it's really listening. And I remember my dad saying this listening to the patient, right? Because they're always right and they always know. And I even learned this in pediatrics listen to the parents. And I think we forget that piece, but that's another piece that will help you solve the puzzle, right? Is if they're telling you something, their disease is telling you something, you need to listen, closely and pick out what can I do with that information? Where will that lead me? And how can that lead me to advancing scientific discovery based on what individuals are showing? And COVID's a great example of that. We really had to look and listen. We very quickly learned patients were having lots of difficulty with clotting in an unbelievable ways and in unusual places. And so that was to me fascinating, a world of unknown. And so, get into the lab, get down to the bench, listen to the patients. What are they showing you? And take that back to the lab. So that's, I think, a really fun piece. So you're probably hearing the excitement from that. And that's how you get to advances in science. It's often the opposite of what you think, right? It's the patient at the bedside that takes you to the bench, and you then bring that discovery back to them.
I know our educators are fascinated as they're listening to this conversation. And of course, we've got STEM educators all over the United States and around the globe that tune into the podcast every week to listen to the advice that comes from the wide range of guests that we are fortunate enough to have join us here on the Tech Ed podcast, Julie. And I want to turn as we kind of move toward the end of our conversation today. A couple more questions left, but one that I think many of our educators may have on their minds. Their job. I'm a STEM educator, science, technology, engineering, and math, of course, whether I'm at the K-12 level, I'm in a community college, I'm in an undergrad program, a graduate program, doctorate program, what have you. As our STEM educators are starting to think about what they're hearing today and also thinking about how they inspire the next generation of professionals in the world of healthcare, what advice would you have for those folks?
Yeah, I think it's so important, your educators, right? And those that you encounter, because it can be just one educator, one teacher that can just spark that sort of energy in a student to then go on and, be a Nobel Prize winner, right? Who knows? But so I think that's what I remember. And it was that biology class. I think it was Sister Bernard, right? It was just like she had a way of really making it fascinating, right? And I think sharing your excitement and enthusiasm, which I'm guessing is really hard as an educator to do that year after year, with maybe most of the students not really caring, right? They just have to get through it. But for those, that are interested, trying to keep that excitement and enthusiasm for the science alive, right? I think you'll draw people in just naturally, right? So it really is their ability to do that. At least it was for me, right? So I give a lot of credit to those educators that I had early in my career.
For you and for many, and we talk a lot, quite a bit on this podcast about I always ask people to think back to their education pathway, whatever that was, and everybody had their own version of it. And pick your two or three favorite, whether it was a teacher, an instructor, a professor, or whatever title that person had. And upon reflection, almost everybody will tell you that it wasn't the one that had the perfect lesson plan. It wasn't the one that spent all the time over the summer coming up with the exact perfect way to teach fill in the blank. It was always somebody that said, that showed that individual. It was always an educator that showed that individual, look, you have a skill that you never knew that you had, or an aptitude that you never knew that you had that you could uncover. Here's an interest that you never explored before. And now you have this brand new interest. Or here's something that you never believed that you could do on your own, never even thought about. And then you had this teacher, this professor, this instructor that showed you were capable of being something that you didn't even know you could be. And that really, to me, is the magic of education, to spark that enthusiasm, that you point to in terms of showing a student that they could be something that maybe they weren't even thinking about, and getting them excited, in this case about the world of medicine, but whatever that career path is. So really, really sound advice, I think, for our educators that you offer here on the Tech Ed Podcast. We have time for one last question. We always love this question. We're going to go back in time. You already talked about a grandfather who was a medical professional, your father, of course, and now here you are following in those amazing footsteps and blazing a trail that I'm sure neither one of them years ago might have dreamed that you would be on, or that medicine in general would be on. But I want to turn the clock back to when you're growing up in that environment. And let's say you're a sophomore in high school, and you could go back in time and give that young lady at least one piece of advice. As you're thinking about that, what would that piece of advice be?
Yeah, I love this question. I think it would be think bigger. If you're comfortable, you're not thinking big enough, right? You need to feel some of that discomfort and push yourself. That's what I would share. And you don't really realize that, I think, till you get a bit older, right?
Absolutely, and the world opens up a little bit more to you, and all of a sudden you realize that there is this incredible planet Earth, and these incredible opportunities, and all of these things that we can accomplish if we think big enough. I would certainly suggest today, Julie, that you're thinking big. Obviously, the career transition you've made in the last several years, the willingness to think even bigger than maybe some of the things that you've done in the past, and just the incredible impact that you're having on so many lives. It's been a wonderful time for you to join us here in the Tech Ed Podcast. I've really enjoyed our conversation. Our guest has been Dr. Julie Panepinto, the Director of the Division of Blood Diseases and Resources at the National Heart, Lung, and Blood Institute of the National Institutes of Health. Julie, wonderful conversation. Thank you so much for being here.
Thank you, Matt.
Fascinating episode of the Tech Ed Podcast with Dr. Julie Panepinto. I learned so much, and I feel so much smarter for having had that opportunity to have a conversation with an incredibly well-recognized leader in the medical community. So thanks so much for joining us for this episode of the Tech Ed Podcast. As you know, all of the show notes and all of the resources that you heard mentioned on this episode are going to be linked up in the show notes. So be sure and visit that. Head on over to techedpodcast.com. This particular episode will be techedpodcast.com/Panepinto, and that is spelled Panepinto. That's where you'll find the show notes for this episode. We have the best show notes in the business, and you will find helpful information there every single week. Now, don't forget, we're active on every social media platform that you can think of, including LinkedIn, Facebook, Instagram, and TikTok, posting all the time about new episodes and other great things happening in the world of technical education. So find us on your favorite social platform, and we would love to say hello to you and connect with you. Thanks so much for being with us this week on the Tech Ed Podcast.